Sure, sure. So, ladies and gentlemen, presenting the last of our finalists, Ankur Chandra from Delhi.
Hi, Ankur. How are you doing?
I'm doing fine.
Well, go ahead with your presentation. Thank you.
Thank you. Tonight, the technology which I'm going to present in front of you is based on position tracking radar, and it's called as cricket engineering. One example which I'd give you is the curious case of Saqlain Mushtaq overstepping. The year is 2001. He picks up 4 very important wickets. The important thing that most of the people missed, but the cameras picked up, was that Saqlain Mushtaq had overstepped on all 4 occasions. Another point I'd like to say are the dubious LBW decisions. Do we remember Paul Collingwood getting Sachin Tendulkar out on 91 in England in 2007, and a disappointed Sachin returned back? That's why I thought that if we have a technology which could track the exact location of where the ball will pitch once it hits the bat or the pad, or we could have the angular movement of the ball. Maybe it did not hit anything, but maybe it moved and it was taken by the keeper behind. So what angular coordinate will it move in? That's where I thought of using a position tracking radar. This is a simple little view of the ground, and this is where the radar will stand. This is at a certain height. It can be at long off, long on, mid wicket, square leg, but it has to be at a certain height. Then we'll have a rolling camera which will track the overstepping of the bowlers. We can have Hawkeye cameras as well, or we can use 2 more rolling cameras, either ways. The PC would be placed in the third umpire's box, and the output generated from the radar antenna will be given in the third umpire's box. Again, the output using the rolling cam will give you the overstepping. We can have a pop-up in the third umpire's box, a pop-up icon on the computer which can show you that the bowler had overstepped. The Hawkeye cams or another 2 rolling cameras along with the radar feed, the radar pulse feed, will give you the exact position where the ball pitched and the exact location where the ball was heading. Thank you.
That was very well done indeed. Judges, over to you.
Once the ball hits the pad, Hawkeye does the predictable, whatever that mathematics, it uses all those formulas to the momentum of the ball, the height of the ball at that point of impact, and then it calculates the predictability theory. Same does the radar. I mean, how can radar, because you don't know what's going to happen after that. It has hit the pad.
I'll again share an example. So the air traffic control, it's not a predictable path. It's not an imaginary path. The pilot and the co-pilot know the path. It's an exact path which they are traveling. They're looking at the map. It's not just hit and trial. It's not an imaginary path. So a radar in the same way will give you the exact path. It will not give you an imaginary path.
You're talking technology, so you can actually define how it's going to be different and what's actually going to be the difference. So you might like to consider that next time.
Thank you very much, Ankur.
Thank you.
Thank you so much.